Hello everybody and welcome back to the channel. Today I have a very exciting video, or probably series of videos. We'll see how it ends up turning out. But today marks the beginning of what will probably be one of the coolest projects I have done to date. And well, I guess I'll get right into it. We're building a Kubernetes cluster. So some of you know I run some services online. I run like a Mastodon and a Matrix server, some other things. And right now those are running on just a single machine that I put together with a Xeon processor and a bunch of RAM and hard drives. Obviously that is fine, but it is all just running bare metal on an Ubuntu installation and it's not highly available or anything like that. So today we're going to be starting to build a Kubernetes cluster. Now what are we going to be using? Well, we're going to be using one of these. This is the Radxa Rock 5B. This is an RK3588 ARM single board computer. But of course this is a cluster, so not only do I have one, I have 2, 3, 4, and 5. Yes, so I have 5 of these Rock 5s, which by the way, it feels crazy to just hold 5 single board computers. This honestly just feels wrong. Why would I have this many? In any case, these are 8-core ARM chips, and each one of these has 32 gigs of RAM. Not with me right now. On the way is a bunch of 2 terabyte NVMe SSDs that are going to be going in each of these nodes, and we're running a Ceph cluster on this, and then also 256 gig eMMCs as well, which is also on the way. But these are for a little bit later, because the star of the show for the beginning here is this, a DeskPi Rackmate T1. This, as you can see by the picture, is a rack, but not any rack. This is a normal server rack is 19 inches wide. This is 10 inches, so about half the size, and it's basically just a cute little thing that'll hold all of the Rock 5Bs, as well as the switch and router and everything else. Also, as a bonus, we even got a touchscreen that can go on there, just on the top, that'll display like graphanographs and stuff once we have the cluster running. So that's going to be really cool. Oh, also these are 2.5 gig, or they have 2.5 gig Ethernet on it. So our network backplane will be 2.5 gig, which is very important for our storage Ceph cluster. In any case, let's get this thing open. If I flip it over, I need to be somewhat strategic here because the Amazon shipping label is directly on the front. There's this handle, something like this. There we go. All right, so here we go. This is the Rackmate T1. There's also a T0 and a T2, I believe, which are just different U heights. I think the U, or like the actual height per unit, is the same as a regular 19-inch rack. In any case, we'll have to consult this to see how to put it all together. I also have in the back over there are the little shelves that the Rock Pis will screw into. And here we go. All right, so this is the top, I guess the bottom panel slash top panel. And these are the actual U's, the covers that you can place. By the end of this, I think we're gonna have like 2 U's available in it. The first U will be the screen, followed by the router, which is a OPNsense router. Then the switch, a UniFi 2.5 gig flex switch. Then we're gonna have 3 U's dedicated for all of the Rock 5Bs, since each SBC shelf is able to have 2 of them. And then we'll the rest is empty for future expansion. So let's see, consulting the manual here. Here we go. Here's all the different sizes. The TT, T0, T1, and T2. There you go. There's an example of what that looks like. Our screen is shorter, so I got the 1U version. They do sell, I guess this is like a 2U or 3U display. You can see how this works, and you gotta get an idea for the size here as well, in terms of it's about 1 mini PC size. In this case, these are the vertically mounted Raspberry Pi rack mounts. Ours are the flat shelves. All right, so I guess step 1 here on the installation instructions is to screw the 2 side pieces onto the actual length, or the height-wise, how would I describe this? Is just where the U's your rack mount screws into. So I guess first things first, we'll lift out this. This is the depth, so I guess that is about how deep the case is. So it's pretty shallow, but that is totally fine for us. Got a bunch of screws, and this is one of the included accessories. This is just a little 1U shelf, as you can see here. So that just screws in like a normal rack to the front, and then we can just plop down or whatever we want on here. For now, this is probably will be holding our switch and router, but eventually I'm going to be 3D printing specific rack mounts for those. That'll be pretty cool. Oh, look at that! We got some feet. That's for one. We also got screwdrivers. That's nice. Look at that. Pretty nice screwdrivers too. Nice packaging. This is the acrylic side piece. I'll take those out at once with their foam. Is that behind me? We got the handles in here, which go on the top, of course. And finally, the rest of the pieces, which have, I guess, slid out of their position there. But yeah, these are the actual places where the rack units screw into. So you can sort of imagine it'll be that, and then the screws line up. All right, so as per the instructions, we shall start out with one of these, and we need to screw one of these brackets onto it, sort of like so. And we got our bunch of screws. I'm going to need to find the KM4 by 16 millimeter. These are the screws that are used for the rack mounting. These are possibly the screws we need. A little rubber feet, and then there are these as well. I'm assuming, given the fact that there are similar looking screws in both of these packets, one of these packets is, or like they're categorically sorted. How? I'm not sure. So I'm just gonna have to guess. That is one half of the rack complete. Now I just gotta slide one of the acrylic panels in, which are these. I guess I shall take the peel off, because I don't think I will be able to get to the peel once it is slid in here. So this will no longer be pristine, I guess, and I do have to be kind of careful. There you go. That's one peel. And because I love you guys so much, you get another peel. There you go. Incredible. That just needs to slide into your off frame. It needs to slide right there. Theoretically, it should be as easy as lining it up and sort of finagling it in there. There you go. That is a completed side of the rack. I lied. This is actually not completed. I need to take the other side and plunk it on here, because of course the rack itself actually has holes on either side, so you can mount rack units facing either the back or the front, or some of them, like the some shelves, will have screws on the front and the back for more stability. All right, so we now have both panels, both sides installed. And they're very precarious because that is not a structural piece, but that is the bottom fan mount, of which you could install a fan. I am not going to, because I don't think I'm gonna need that. But now I can do the next part, which is the top, which will actually be structural. Those are the two aluminum rods over there. And there we go. That is the two support brackets. And I mean, at this point, this is a solid piece. So I think all that's really left is the handles and the little top piece. And we've gotten ourselves a 10-inch rack. And there we go. That is the completed rack. I mean, without any of the the shelves or units in them. But there you go. That was pretty easy to set up and feels nice and solid. We got the two handles on there, the acrylic top panel, place for fans if you want that on the bottom. And yeah, so I think at this point we can put the display that goes right on the top. We'll leave 2 spaces or so for the router and switch. I'll wait for those to arrive just to see what I know the UniFi switch will fit in 1U, but I didn't actually check the dimensions exactly of the Protectli router that's gonna be going in here. I'll explain the whole setup with OPNsense and the networking and Cilium and all that stuff later, but we'll start with just the physical installation. The other thing is I have all of the Rackpis, but I don't have the eMMCs or the NVMEs yet, so I don't want to screw them into the board. So I think this is all we're going to be doing for now. So let me get the screen in. So here we go. This is the display. If I kick off these little protective things, so you can sort of see what's going on. It is actually a lot nicer than I thought it would be. This is a glass panel on the front with the touchscreen, and then on the back is just HDMI and USB-C for the touch and power. And this will pretty much just sit like that in here, and we will eventually, once the cluster is running, we'll have statistics, graphs, utilization, that kind of thing showing up. So just mostly for fun. It's not necessary, but it will be cool to see stats of what's running in the cluster just by looking at it at a glance. Since I'm already on the ground, I might as well continue. Here is one of those Rock 5Bs, and I guess since I'm here, I might as well do the heatsink installation. As you can see here, a little fan and heatsink. So might as well install those. Two oddly shaped, well, this is a normally shaped thermal pad. This is a slightly oddly shaped thermal pad, since this is the CPU one, and then this goes around it to cool some of the peripheral stuff, I guess the RAM and whatever. We'll see how that lines up. But here we go. Here's a fresh Rock 5B32. Beautiful. And there we go. That is our, and this, I believe these are the blue edition. I'm actually not entirely sure what makes the blue edition different. As far as I can tell, nothing. They just did a run of these with blue PCBs and they're slightly cheaper. But yeah, there we go. This is the board. We have our M.2 NVMe SSD slot, micro SD card slot, and eMMC slot right there. And of course, the star of the show, the Rockchip RK3588. One of the reasons I really like this chip is because it has really good mainline Linux support these days, thanks to the work of the people over at Collabora, which honestly, I think at this point, this might actually be a more well-supported Linux board than Raspberry Pis, funnily enough, since you can install a UEFI firmware on here and just basically boot any distribution that has a recent enough Linux kernel, just straight from a USB disk. Like I can just flash an ISO, plug it in here, boot it, and install to the SSD, which is what we're going to be doing. Some of the details still up in the air, but I'm probably going to try out Fedora server just so I can get a relatively recent Linux kernel on here. And of course, the other star of the show, the 2.5 gig NIC, that makes this a pretty decent node, particularly because we're going to be using Ceph for storage. So we're going to want Ethernet. I mean, obviously 10 gig would be even better, but 2.5 gig should suffice for our needs, and that's powered by a little Realtek chip over there. There's also this M.2 slot, which is E-keyed, I believe, for Wi-Fi, Bluetooth, which of course we do not need. Also, there's an HDMI input on this board, which is kind of interesting. It's just a feature of the RK3588. And depending on when you're watching this, 2 RAM chips for 32 gigs of RAM, which is quite a commodity these days. In any case, I believe the way this will work is the heatsink will go, or I should say the thermal pad will go on something like that to cover up those RAM chips. I guess they could also go this way to cover up some of the, or I guess not. They could go this way to cover up some of the, like the PMIC and things. Not entirely sure what direction they want me to go, so I guess I'll look up some directions online and I will get back to you guys. So I've discovered one thing. There is a single orientation where this actually fits, which is this orientation. You can see it cuts out for that pin header and everything. Because of that, we need to use this hole for the heatsink mounting, which means that this is an invalid orientation because that would cover up the hole, which means I guess the RAM does not need cooling, that does track. RAM usually doesn't get too hot, so we're going to be using this orientation, which will cover up the PMIC chip right here, which is probably the thing that's going to be getting hotter. You can see the cluster of capacitors down there, which of course the PMIC, this is the power management chip that's actually supplying voltages to the rest of the board. So I'm gonna toss that on. All right, and there you go. That is the mostly straight outer heat pad installed. Now he's got to grab one of the square ones and plop it right on the 3588. All right, there you go. So now the heatsink is on. I just got to squeeze these in once it's aligned with the holes, and that should be the heatsink installed. Oh, and of course, then I have to plug in the fan header. All right, after a little bit of finagling, these pins have gone through, as you can't see. So that heatsink is now officially mounted. Now I just got to decide how I want to route this fan cable, probably something like that around the header. And there we go. The little JST connector is in there, and that's it. That is a completed heatsink installation, of course. In the coming few days, I'll get the eMMC, which actually should be arriving in about 2 days, so we'll snap that in there, and then in about a week or so from now, the NVMe SSDs will be arriving. Of course, I bought those used on eBay, since I am not that wealthy that I could purchase 5 NVMe SSDs brand new, but a trade-off I'm willing to make. Also, they were 100% health drives, so should be fine. And there we go. We got 1, 2, 3, 4, and 5 beautiful Rock 5Bs with their heatsink all in place. That is probably going to be it for today, depending how long this video ended up being. This is either going to be a part 1, or there will be now a cut to me doing more stuff, potentially. There's still obviously lots to do. I guess I might as well recap a little bit of what needs to happen. Obviously, for these nodes, we still need the eMMC module, which is going to be the boot drive, and then the NVMe SSDs will come a little bit later. Once we got the eMMCs, which will be coming in like 2 days, we can start installing operating systems on this and actually start bootstrapping the cluster to some degree. Tomorrow, the Protectli router is coming, so we can install OPNsense on that bad boy, and also flashing Coreboot on that, because that's one of the nice things about the Protectli routers is that they support Coreboot. Though because I bought mine from Amazon, it'll come with AMI BIOS, but we can flash it pretty easily. Once these nodes are set up, they can be placed into the rack. Once the router and the UniFi switch arrive, they can be placed onto the shelf, probably temporarily until I get my 3D printer back in order. And that will pretty much be it for the physical setup of the rack. Then it gets into the fun part of obviously configuring this. We're gonna have to bootstrap Kubernetes on here. We're going to set up Cilium for networking, BGP for the load balancers between here, the nodes and the router. We're going to have to set up Rook Ceph for storage. And then, of course, begins the interesting task of, and something that I've not really thought of too much yet, which is how we are going to actually transfer all the services over to here. So we're going to start writing lots and lots of YAML. So yeah, I guess we'll see what's next in the clip. Transition. Oh, we also have to flash UEFI. That was the other thing I was going to mention on here. Each of these, I don't know what is on here by default. Uboot, potentially. I don't know. But there is a project that has ported EDK II to these boards. So we're just going to have to stick a micro SD probably in each one of these with Ubuntu or something, like a Rock 5B image, and then use that to flash EDK II, I believe is how that works. So that'll be next. Okay, so here's the situation. It's the next day, and I have one of the Rock Pis running on the bench, as you can see here. We are logged in. I have Fedora KDE installed, and it's working perfectly. And I even have Minecraft running, just to see what the performance is like with the integrated graphics. This is actually running on Zinc because the I guess the Panfrost drivers don't have a new enough OpenGL version, so we can use Vulkan to convert to OpenGL. As an aside, setting up the EFI firmware on this was actually a lot easier than I thought. I originally thought I would have to boot into a Linux distribution first and then flash from within the operating system, and I think that is an option, but it's actually a lot more convenient than that. There's just a mask ROM button just on the side here, and then you plug the entire board over its USB-C port just straight into your computer by holding down that mask ROM button, and it'll enter a flashing mode, in which case you can just use the RK Develop tool to just flash the UEFI firmware straight from your computer without having to actually boot this thing up, which is very nice. And I'll show you guys when I do that for the rest of the boards. It's pretty much just like flashing a microcontroller, right? You put it into flash mode and then you just run a command. So that's really nice. It's also nice because for some reason the Debian image was not booting off my SD card. So anyway, that's besides the point. There has been quite a bit of things that have happened to get to this point. Namely, we ran into some power issues. So this brick right here is the 30-watt Radxa power supply that I bought. I have 5 of these that I bought specifically to power these boards. However, it has come to my attention, and I think I might have mentioned this in passing a little bit earlier in the video, but if I haven't, basically USB power delivery is a little bit cursed on these boards. And what I mean by that is, well, the long and short of it is that when you plug a USB-C power supply into the power input on these boards, PD negotiation doesn't actually take place immediately. The USB-C PD chip that is, connected to the CC lines on the USB port that chip is actually driven by the Linux kernel and or the firmware, but it's not really implementing with the firmware, so it happens in the Linux kernel. Now that's the first bit of curseness that I mentioned, I think, earlier, which is basically that because the PD negotiation takes place at the kernel level, it's delayed, right? So the board will start up at 5 volts, and then when the kernel loads, it'll do the PD negotiation to switch up to 12 or whatever volts. The problem with that is that some power adapters really do not like the fact that no PD negotiation takes place immediately, right? There's that delay between the board powering on and us booting far enough into the kernel. So some power supplies don't deal with that correctly. I think that is technically out of spec, I'm not really sure, but either way, a lot of power supplies have problems with that. So I specifically bought these Radxa ones because I know that they have no problem with delayed PD, because of course they were validated to work with the Rock 5B. However, the problem is that we are not running the Radxa vendor kernel or the Rock chip vendor kernel, which is like a 6.1 kernel or whatever. We're running mainline Linux. So if you see here from our fast fetch, we are running just the standard Linux 6.19, the mainline Linux kernel with the Collabora drivers on this board. Now the problem is, I guess, honestly I'm not entirely sure, but I guess the long and short of it is that the mainline kernel doesn't do PD negotiation, and or there's some weirdness with the UEFI firmware. And I was actually able to validate this because I actually forgot I have one of these. It's a little USB-C power tester, so you sort of just plug it in one end into your device or your power supply, and then it passes through power, and it actually shows you the voltage and current that is flowing through it. So with that, I was able to see that, indeed this was not actually negotiating up to the 12 volts, I think is what it would, or 15, or whatever it would prefer. So the solution then is a little cursed. So first of all, this USB-C port here, right, is obviously designed for USB-C power delivery, which means that yeah, it's designed for 5 volts, but also it's designed for up to 20, because the way that USB-C power delivery works is a USB-C power delivery supply will start at 5 volts, and then a device can request more. And so when that voltage goes up, that goes over the same V-bus pins that the 5 volts was originally at, which means that the 5 volt input on this USB-C port is capable of taking up to 20 volts. So nothing is actually stopping us from using it. It's been sitting here right here. This is an example of what's running on that Rackpi right now. This is a 12 volt, 3 amp power brick. That is just a fixed, dumb 12 volt power brick. It terminates at a regular barrel jack. And then I have one of these. Now this is where things get a little cursed. If you see what's going on, I think you know exactly what I did. This side's a barrel jack. This side is USB-C. This is a passive adapter. There is no power delivery negotiation or chips, all right, of any sort. Really, this is meant to be for if you have a 5 volt barrel adapter and you can plug it into a USB-C device to charge it, or I guess the other way around as well, like if you want to get 5 volts into a barrel jack. Either way, basically, what I've done is this. I've plugged a 12 volt barrel jack into this USB-C adapter, making possibly the most cursed USB-C plug, because of course this is now a very dangerous plug if you don't know what you're doing. However, this works just fine. That's exactly what's happening here. If I look up, you can see, there it is, barrel jack into the adapter into the Rock 5B. So the Rock 5B is just booting straight up from 12 volts. And it works. I did a little bit of testing beforehand, just making sure the polarity is correct. This is all center positive. That's all cool. And of course, the Rock 5B is capable of going up to 20 volts, so really there's no problem with that. So yeah, it totally works. I've just been stress testing with Minecraft. I'm on the Minecraft Rapid Transit server. Probably throw a link in the description, why not? If you like city building and transit, this is the server for you. Anyway, that's a shout out to that server. But yeah, it's been working great. So I guess this is the solution. The other thing that has occurred to me is I might actually be able to use these bricks because they do actually support a slightly cursed spec, which is 5 volts at 5 amps. Of course, that requires a thicker E-marked USB-C cable. But honestly, I'm probably just going to go with this solution, because I guess it probably will end up being more reliable in the long run, just to power this off 12 volts. And of course, 12 volts at 3 amps will give us a little bit more headroom than 5 volts at 5 amps. So I think this is probably the better solution. Load-wise, we don't have an NVMe SSD on here right now, but we do have this StarTech. I've just been using this as just a boot drive for testing. It's a dual SATA M.2 SSD adapter, so I think that's probably representative of an NVMe plus the eMMC. So I think power-wise, we are pretty much good to go. But yeah, that's good. The eMMCs are going to be arriving tomorrow. The NVMEs are somewhere in the eBay shipping center, DHL shipping center. So those will show up someday. One slight annoyance is I bought this power strip, which is just a kind of an industrial style power bar. Originally, I was going to use the Radxa power adapters on here, so the spacing is totally fine. The problem is these 12 volt adapters are actually quite wide. As you can see, they're a lot wider than the Radxa power adapter, so I actually cannot just put them next to each other. So I'm gonna have to get a new power strip, which is kind of annoying, but oh well. Also, theoretically, these things are UL listed or whatever, so hopefully they won't just explode, but I guess that's the beauty of having a Kubernetes cluster, of course, is if any of these nodes die, then that's only a mild inconvenience. The point is that we're supposed to have high availability, right? So the actual, that's why these nodes don't need to have RAID or anything on them, right? We don't really care if a node dies. I mean, if multiple nodes dies, then that's a problem. But the idea is we're redundant at the node level. So, just a single power supply, single SSD per node is sort of totally acceptable. Before the eMMCs arrive tomorrow, there's actually something I do want to do tonight, which is this lovely box that came in today. This is, of course, the Protectli router that will be doing the routings, will be where all the LAN and VLANs for all of the whole cluster will be set up, as well as the important part of the reason why I'm getting a separate router at all, which is to run WireGuard. I don't know if I've explained this yet, but basically the way this is going to work is rather than having the cluster exposed through my local ISP's dynamic IP, I'm going to be setting up a VPS in the cloud with a static IP and also a an entire IPv6 subnet, and we'll be using WireGuard to basically tunnel all of the entire cluster up there, and then it'll use that as its internet ingress and egress. So all the port forwarding and stuff will be happening through that cloud IP. We'll get more into that later once I have it all set up, but for now, let's unbox this little Protectli vault. One of the things I like about the Protectli vaults, of course, is that they run open firmware. You can pick when you purchase them on their website whether or not you want the standard AMI proprietary BIOS, or you can actually run Coreboot on these things, which is pretty neat. So there you go. That is the router itself. It's a 2.5 gig router. What else is in here? I think there's like an SSD tray, and there's the power supply as well. There we go. We got a quick start guide, SATA cable, USB micro B cable. That, if you're curious what that is for, nice feature of this router is you can, of course, plug, if you go to the other side, we got a whole array of, PC. I mean, this is basically just a mini PC ports. So you can plug into HDMI, you can plug into DisplayPort to set this thing up, or you can use that console port right there, which is a micro B on this model. Some of the newer models are USB-C, and that'll give you a serial port. So there's a little FTDI chip in there, and you can set this thing up over serial, which is really nice. We got ourselves power cord, power brick. Of course, that is a channel well technology, 12 volts at 3.3 amps. And that's pretty much it. There's a mounting bracket, some screws, and the SATA power cable. Now, I bought this particular Vault unit on Amazon, which means it's going to ship by default with the AMI BIOS. Our first course of action is to boot this thing up into just a regular Linux distribution, and then we can actually flash the Protectli official Coreboot on here, since, of course, given the chance, yes, I will take the open source firmware. Also, I don't know if I mentioned, these are 2.5 gig network ports. All right, we have the Protectli router firewall plugged in power, as you can see back here. And I just have it booted up to Fedora KDE at this point, specifically so we can go and flash the BIOS. So like I said before, because I bought this from Amazon, it's coming with the AMI BIOS by default. You can order these from the Protectli website with Coreboot as an option, but because mine came with the AMI BIOS, we can just go in and use their Flashly tool, which is just on GitHub, I believe, to just go in and flash Coreboot ourselves. I will go through these steps, which is pretty much just git clone and run the program, and we'll reboot, and hopefully we will have a router running open source firmware, which is going to be pretty sick, because pretty much this entire stack is going to be running open source firmware, because the router, of course, is running open source firmware, and all of our nodes are also running open source firmware, because we're running the EDK II UEFI firmware on there. I guess the only thing in the stack that's not open source is going to be the UniFi switch. All right, I have you guys on the tripod, so if anything goes horribly wrong, you'll be here with me, but we should just be able to do sudo/flash BIOS, and it should just work. I guess it'll auto-detect what platform we're on, and hopefully we'll flash the correct ROM image. We are on a VP2420, so we must disconnect and reconnect the power cable in order to fully complete the update process. Failure to perform these steps will cause your VP2420 to fail to power on or behave erratically until rectified. Interesting. All right, so I guess on the other platforms you would normally reboot, but I guess for whatever reason, when the BIOS gets switched out at runtime, the computer's at a cursed state. That's a little concerning, I will not lie. We're not completely screwed, because I do actually have this little I2C ROM flash clip, the little SOIC8 clip, and that should probably work with this. I have that from flashing Coreboot onto other things. So if this does fail, we do actually have a way of opening this up and directly flashing the BIOS chip. In any case, let's hit Y and hope this works. We get to pick, so we can go back to the AMI BIOS if we want to, but no, we want to go to Coreboot next, and then the final acknowledgement. I acknowledge that, yep. This is good advice. Really, you should probably just stay with the BIOS that you have, but of course we're always going to take the option of open source BIOS. And it failed. That is actually not that surprising. You know what? We are probably booted with, I'm opening the wrong thing. We are probably booted with, if we go over to Info Center, I bet you we're booted with Secure Boot, which means kernel lockdown is enabled, which means that writing directly to the flash ROM is blocked. Oh, actually, no, we do not have Secure Boot on. So, and kernel lockdown is actually off. So that is not what that is. Interesting. All right, well, I will do a little bit of Googling and see if I can figure out why this works or why this didn't work. Okay, so as you can see here, I've rebooted Fedora. I'm at the grub menu. I'm gonna try this kernel parameter, IOMEM equals relaxed. And we'll see if that's enough to actually allow us to use flash ROM. Also, you can kind of see me. Ooh, hello. All right, we are back to where we were just before. Now booted up with IOMEM equals relax. Let's hit enter and let's see if this works. Okay, it's going. It's reading the old flash chip contents. I believe what it's about to do now is it's going to read the original flash chip, as you can see there. It'll swap the BIOS section out with Coreboot, but it's going to leave the flash descriptor and the Intel Management Engine section. So there are, yes, the Intel ME backend or backdoor is still going to be there, but our main BIOS is going to be running Coreboot still. This is a relatively recent platform, so I don't really know what the state of removing ME is anyway. But I'll get back to you guys when this is done. All right, it is done. The instructions are pretty clear. Remove the power supply from the device and reinsert it. So I guess we're in that cursed state right now. So I'm just gonna come in here and unplug the power. Just like that. And I will point you guys back at the display. I'm gonna plug power in, and hopefully this will boot up into Coreboot. All right, we got a beep, and there we go. Hit delete, we can go into the BIOS setup. Hey, check that out. It's a very small setup. But there you go, we're running Dashero Coreboot with UEFI, and we can kind of see, I mean, there's like, you can set a password and all the kind of things you would typically do here. Secure boot configuration. I'm not actually sure if OPNsense supports secure boot. Awesome. We might as well set our power state here. There's also some CPU thermal throttle offsets and some other things. Serial ports, which of course will map to that USB. Awesome. So we can boot back into Fedora, I guess. I mean, there's not really much else to do here. But there you go. That is the Protectli VP 2420 running Coreboot. Now we've got to install OPNsense. All right, it's the next day, and I'm happy to report we got the eMMC module. So I think at this point, the only things we're missing are the NVMe drives, which are going to be our Ceph storage drives, and the Flex 2.5 switch. But since we have the eMMCs now, and since I can use just a regular gigabit switch in the meantime, I think we have pretty much everything we need to start bootstrapping the cluster. So that's going to be really exciting. We still have to install OPNsense on the Protectli router. You can see it's still booted up into Fedora KDE. But these eMMC modules are going to be the storage for the OS on the Rock 5Bs. And I mean, you can kind of just see they're just little cute little eMMC modules. I slice one of these packagings open. There we go. That's it. It's a little 4C 256 gig eMMC. Now, as you probably have noticed, these are Orange Pi branded modules because those were what was available. The Radxa ones were not in stock. However, they should work as far as I understand, so I guess we'll find out together. Here is one of the Rock 5 boards. Theoretically, you can see the little triangle notch there and the triangle notch on there. I'm doing this from behind the camera. It should line up, and there you go. Snaps in. I think one side snapped in, other side has snapped in. There you go. Perfect. That is eMMC installed. So this now has 256 gigs of NAND flash. Now I've got to do that for the other 4 boards. All right, just to be responsible, before I started installing the eMMCs into all of the other boards, I booted up the board with the eMMC, and as you can see on the terminal over here, it is indeed detected. And we can see in dmessage that this MMC0 is running at the HS400 speed and is detected correctly. So that looks good. Okay, now I can go in and actually install the eMMC into all of the other boards. And then after that, we can start racking stuff up. Since I don't expect the NVMEs to be coming it's probably going to take more like, if the shipping estimate is to be believed, it's going to be like another 15 to 20 days before I get the NVMe SSDs, which kind of sucks. Thanks, DHL. But yeah, so I think it's worth just racking stuff up now so we can start getting stuff installed, and then when the NVMEs come, we can deal with that at that time. All right, that's all 5 nodes set up with eMMC, 256 gigs. I don't know if I've mentioned this before, but one of the nice things about eMMC, they use the same kind of communication standard as microSD, though at a faster rate, and also the eMMC specification has extended capabilities for things like trim support and bad block reporting and stuff like that. So they operate much closer to, you know, like a SATA SSD or an NVMe SSD compared to a micro SD card, and typically are going to just be more resilient NAND as well. In any case, I think now is the time we start screwing these into the shelves. So let me go grab those and we can start racking these things up. I will say, when it comes to this project, it is very interesting that I have to buy so many of things, right? We got 5 nodes, 5 eMMC modules. I need 3 of these shelves. Definitely feels very interesting it feels wrong, honestly, that I'm purchasing so many of these things. Anyway, if I take the other 2 boxes out of the way, we have our SBC shell. I'm assuming that's meant to say shelf, but in any case, instructions should be pretty straightforward. If you don't know what this is, it'll be very clear very shortly. It is a little 10-inch 1U rack shelf for SBCs. So if you flip it over, you can see there are all of these holes that correspond to different modules that you may install. So there's a 2.5-inch SSD HDD mount. I think some SBCs actually follow that footprint. We have the Raspberry Pi footprint, Jetson Nano footprint, and for our needs, the Rock Pi 5B footprint. So as far as I can tell, we just need to put little standoffs on all of the circular holes, and that'll allow us to have 2 SBCs per rack unit. Okay, so I've gone ahead and organized all of the screws here. There's a set of 4 tall standoffs, a whole bunch of these shorter standoffs. These, I'm assuming M2.5 and then M3 screws. Okay, so these standoffs are all M2.5. There are these couplers, which I sort of imagine are meant to, because these holes are not threaded, right? They just go through like that. And I assume you just put something like that on there and hold it into place. I imagine that is seemingly the only way that works. So we have one board installed. As you can see, what I've ended up doing is using screws on the bottom, and then as the standoffs, I have used these little doohickeys. The reason I went with these instead of the normal standoffs is actually because if you look, the M.2 socket, it's actually, well, in here it's not touching, but with these standoffs are a little bit shorter. As you can see, they're a little bit shorter. So I used the longer, I don't know, like dual female standoffs to get more height. And then for actually screwing it in, because we don't have enough screws, you know, these silver ones, I took out my set of M2.5 screws. I'm just using these short ones to affix the board to the shelf, and that has worked perfectly. And as a bonus, check that out, the cutoff, I realized, is perfectly lined up for an NVMe SSD. So if I take this example NVMe SSD here, I can just insert it into the socket and I'll be able to screw it in perfectly. So that's really nice. So I can actually essentially permanently install these now. I can tighten these down, and come, 15 to 20 days from now, I can throw the SK Hynix NVMEs as they come in. So I will now proceed to painstakingly install 8 screws, 8 standoffs, and then an additional 8 screws per shelving unit. And I'll get actually -4 because we have 5 in this. Anyway, you get the idea. I need to do the process of installing all of these, and I will get back to you when that is done. All right, we are back on the floor, and as you can see, we have all 5 nodes installed into the SBC shelves. I had just enough of these M2.5 screws, but yeah, there you go. These look freaking awesome. And now we just gotta throw them in the rack. And then once that's done, we can start wiring up power, Ethernet. Obviously, I don't have the Ethernet cables, the final Ethernet cables. Those will be UniFi, the UniFi premium cable or whatever, Ether lighting cable. But we'll put something in temporarily. We'll put a gigabit switch in temporarily, and we'll fire all these up and then go through the process of installing Fedora server on each of them, as well as we also have to go through and set up OPNsense. So lots to do, and then that's probably going to be the end of the episode. We'll see. The UniFi stuff hasn't shipped out yet, so I don't know how long that's going to take. If it's going to ship out like today or tomorrow, then I'll chuck that in the end of the video. Otherwise, we'll get everything set up with a gigabit switch. We'll throw everything in the rack, set up OPNsense. I'm not going to torture you guys with having to sit there and watch me stumble through the process of actually setting up a Kubernetes cluster from scratch. But in any case, let's get these racked up and check that out, ladies and gentlemen. We have all 5 nodes installed beautifully in this rack, as well as our shelf. And then hello, you can see me in the reflection of the display, HDMI display for our graphs and such. But yeah, there you go. All of them are installed. We're gonna throw a switch into this shelf. Eventually I will 3D print a bracket for the Flex 2.5 when that arrives. Same thing with the Protectli router. For now, said router will just live on top like that. And yeah, well, I guess it's time to get things powered on and installing Fedora, and we should be able to get a freaking cluster. How cool is that? All right, so I have the Protectli router plugged in, power about to be plugged in, and I have the USB console connected up, and I have screen open here. So theoretically, I have flashed the serial installer of OPNsense. We should actually be able to just plug this in, and hopefully we will get serial console output here in screen. There you go, check that out. We're in the BIOS over the serial console. That's pretty cool. So we should just be able to go one-time boot and select our Elecom USB. And there you go. Look at that. Boot multi-user. And hey, there we go. We are booting OPNsense off the USB over the serial port. So that is pretty sick. And there we go. We've booted up the installer. So I should just be able to log in with installer. And the password is OPNsense. Hey, there we go. And at this point, it is going to be a pretty regular OPNsense install. So I'm just going to go with the default. We'll install with ZFS. Why not? Even though we only have one drive. We'll go stripe, no redundancy, because we only have a single drive. I could add a second drive in here eventually at some point. So that's something to think about. 88.0, this is our SATA SSD that's inside the device. eMMC 0 is actually, there's a built-in eMMC that we could also install to, but we'll install to the SSD. In any case, we'll let this run, and I'll get back to you guys when we have a fully installed OPNsense. All right, so we have all of the nodes racked up, and I have just this Netgear gigabit switch for temporary purposes until the Flex 2.5 arrives. You can also see I just grabbed myself an assortment of slim Ethernet cables. Again, I have correct length UniFi cables coming eventually, but this will work. And the router, OPNsense router, is installed, set up. Up here, the Ethernets are on the back, and that's what this cable is. The uplink to the router. Now, the only thing I actually forgot to do is I still need to flash UEFI on all of these. So I'm just gonna have to pull out the barrel jack adapter and then just plug my computer straight into each one of these. Should be relatively straightforward. The only annoying thing is I'm gonna have to get to the button, which is, you can kind of see if I get in here, is just behind the fan cable there. So I'm gonna have to do a little bit of gymnastics to hit that button and then plug it in to boot into mask ROM mode, but it should be okay. Okay, so I have this USB-C cable plugged in to my computer, and basically what that does is it brings up the Rock 5B into mask ROM mode. And basically, you know, if you're used to like Android, this is like ADB, or it's actually closer to fast boot is what this is. But it's a little bit more primitive than that. When you're in mask ROM mode, the only thing you can do is stream a bin file for the board to boot up. So what you do is you basically go arcade develop tool, you see your things in mask ROM. Then there's a loader file that you stream over. And what that does is it'll give your board extended functionality. So the actual ROM that's we're booted into right now on the board is, you know, very minimal. But once you load this loader into memory, that'll give us access to more functionality, specifically for us, the ability to write to the SPI flash. If I just run this, you'll see it'll download the bootloader onto the Rackmate. And at this point, what we can do and there you go. Board is booted up into UEFI, so now I've got to do that for each of the rest of the boards that are not flashed. All right, so node number 1 is up, and we're going to install Fedora. I don't know if I mentioned this before. I could technically do something with like Pixie Boot and Ansible and like have all these install all at once over the network, but it seemed like it'd probably just be easier to go through the installer on each one of these. So that I will do, and we'll just get these installed with just a bare bones Fedora server. If I haven't mentioned it already, the reason we're going with Fedora and not something like Debian or CentOS is specifically because I want to run the mainline kernel on these. And so I want to run something pretty recent in order to get all of the latest drivers, since these platforms are all pretty new in terms of mainline support. Obviously the RK3588 has been around for a few years, but mainline development is pretty recent. So I wanted to run something like Fedora server. 1, because big fan of Fedora, and 2, because new kernel. But yeah, something like CentOS would make more sense. There is also the option of running CentOS with a new kernel. Like there are, I think, repos that will give me a new kernel, but might as well run the latest and greatest on this cluster. Oh, also, if you were wondering, yeah, I could have installed Fedora once on one of these and then flash the eMMC, like create an image of it and then flash it to the other 4 nodes. The only problem with that is I didn't buy an eMMC USB adapter, so that would have been kind of annoying. So this is how we're doing it. Anyway, there goes the Fedora install. We'll let that cook. So it's a little bit noisy because the 3D printer is running, but I have my Ender 3 V3 SE here that I actually just replaced the nozzles of the build plate because they've been kind of worn out. In any case, I do have a little bit of a setup going. Normally, well, once upon a time I actually had Clipper and an Orange Pi here, but then that died. I've been too lazy to reconfigure that and recalibrate Clipper, so I'm back to the original firmware. So I have for a little while been just using the SD card and the onboard interface to print. Though I decided to change things up a little bit. I have my MacBook Neo here, and yeah, if you wanted to see more coverage of MacBook Neos doing weird things, the MacBook Neo behind here, I have my dock and a webcam and a USB-C cable. And I assume you guys, well, you can see exactly what's happening. I'm running Octoprint on the Neo in a virtual machine. So I have just UTM with Fedora KDE, AR64, and it's running Octoprint in Docker. The 3D printer and the webcam they are both USB pass-through into the virtual machine. And so I can just access the Octoprint interface. So this is just using the standard firmware. And yeah, I just upload the G-code straight from Creality Print. Usually I'd use Cura, but again, it's been a little while since I've used this 3D printer, so I decided to try out Creality Print again, which I believe this version is based on Orca Print. Oh, the fan turned off. Anyway, this is based on Orca Print. In any case, the first thing we're printing here is the USW Flex rack mount. So this is the our 2.5 gig UniFi switch. Hopefully this works out well. I'm printing it in white PETG, so hopefully that'll look pretty nice on the rack. It'll match the Flex switch. Of course, we are waiting for everything to heat up, and it's doing its first pass there. That's its purging the nozzle. And hopefully this will print and actually stick. There it goes. And of course, we have the webcam pointed at it, so from within Octoprint, I can watch all of this. I don't know why it's flashing. I guess that's probably a bug somewhere in this cursed stack, but this does appear to be working. It does appear to be sticking. So yeah, there you go. That's the new print set. Oh, I also have this filament heater that I'm not using. Back when I had the whole Clipper set up, I also had a little 3D printed guide for the filament. But anyway, yeah, this is the current setup. I think it's pretty cool. This server is not doing anything. It's just a stand for the Neo, I guess. But yeah, there you go. That's 3D printing with the MacBook Neo, I guess. Oh, and I guess everyone wants to see the memory pressure. I think I have 5 gigs allocated to the virtual machine, so we're using like 4 gigs of swap. I can make that a lot better if I just close Firefox, since I don't need to be down here anymore. I can go upstairs. There you go. There's the memory pressure sort of back under control. Yeah, that does appear to be printing pretty well. The estimated time on this is about 4 hours and 15 minutes, so we'll see how accurate that is. It's currently 12:31. You can also see the design that I'm printing here is the dual pass-through design, so we can feed a cable through either side, depending on how we end up orienting everything in the rack. Yeah, I'll see you guys in about 4 hours. And there we go, ladies and gentlemen. The print is completed, and it's looking pretty good, actually. Turned out very nice, I would say, overall. So, conveniently, the UniFi switches also showed up. So let's go unbox that, and we can install it in here. Oh, and also I'm going to get the next print started. Next up is the Mac Mini rack mount. Also, I forgot to do a time lapse for this. I didn't enable the option in Octoprint, so I'll get this printing and I'll also turn on the time lapse feature. So hopefully you guys will see a time lapse right now. It really is quite a sight of just seeing so much UniFi gear in one box. And it's funny because it's not a lot of things. This is the Flex 2.5 switch. This is the Flex Mini 2.5, and the rest of these are just an assortment of UniFi patch cables. Some for this project, some for other projects. Just to have some patch cables around. Anyway, we're here, of course, for the star of the show, the Flex 2.5. Might as well do a quick unboxing of this on camera. Always love the kind of premiumness of the UniFi gear. Let's get this out to the side here. You can see we got the power brick. I guess we'll pull out first. There you go, USB-C power brick. For those curious, this is a 5 volt, 3 amp power supply. Then the Flex itself, this is a couple things. Number one is it is a little spirit level, which you can actually pick which orientation you want that. And then it is a template, so you can throw this on the wall if you're wall mounting this, and then you get a built-in level and you can drill your requisite holes for the included wall mount. But we are not going to need that. All we care about is this little switch, which is honestly just, look how cute it is. It's so thin. Yeah, we got 8 2.5 gig ports and then 2 10 gig ports. I believe it's an either or situation. As you can see here, it's labeled as port 9, so you can do either SFP or RJ45 for your uplink. We of course not actually going to be using 10 gig, at least not for now, since our router is only a 2.5 gig router itself. And there you go. That's the Flex 2.5, and you just start with USB-C just like that. Now, of course, we're going to be combining it with our matching 3D printed adapter. If I remember, I'll put links to all this in the description. But in theory, if I slide this over, this should pretty much just friction fit right in. And there you go. That's it. It's just sort of friction fitted in there. The rubber feet give it a little bit of stability, and then this is open. And that's it. There you go. That is a 10-inch rack-mounted Flex 2.5, of course. I bring the power supply over here. Of course, the power supply can come in from the back, and then these little openings are perfect for running the cable. So you can run it just like that. I can probably run another Ethernet cable through here, or if I want to bring another Ethernet cable out, I can do it through that side. So there you go. This can now go into the rack. Oh, also, some of you are probably wondering, an Ethernet cable can actually just barely fit through this opening here. The only catch, this is the UniFi premium ether lighting cable or whatever. The catch is that you can't have a boot on the connector. So you can see how this one, there's just a clip but no boot. That'll fit through on this particular model, but like this cable, for example, has that boot, and that extra little bit of thickness will preclude it from actually fitting through here. So that's something to keep in mind. You can very easily go into like Tinkercad or whatever and just modify that opening to be a little bit larger if you need, but in my case, it works perfectly. So I can just fit a standard UniFi Ethernet cable right through there, and I can stick the USB-C through there, and then I can have my uplink connected here, and then we'll get this installed in the rack. All right, there you go. It's racked up, and I think it looks pretty good. Unfortunately, as you can probably immediately tell, the screw holes don't actually quite line up. Well, I mean, this one actually lines up, which is kind of funny, but not on this side. But yeah, the bottom screws don't actually line up for whatever reason. So 2 screws it is. I mean, that's fine. But yeah, there you go. The cable pass-through works just fine. You can see me in the display over there. Now we've got to get our patch cables, hook those up, and this is going to start looking pretty nice, I think. One thing I was sort of considering is, of course, this screen right here. The Protectli, oh, my glasses. The Protectli router is about 1.5 views. So putting it right at the top actually makes a lot of sense, because you have this kind of half view of space that you can't actually use like this. The reason this whole thing's offset, I don't know if I've already mentioned this, the reason this is offset is that this screw hole like doesn't line up with the rest of them. So this top screw hole would then interfere with the top of the display if you were to put it up there. So this whole thing is shifted down by half a U. If you put the Protectli router right here, then it would actually cover up that gap. But I kind of want the screen at the top. So I was thinking maybe I could put the Protectli console here and then the screen under it. So the screen would be right here, which I think is an acceptable middle ground. But then I've already put all these in. I don't really want to get rid of all of this. So I think the Protectli console will probably go at the bottom where it'll have a load of extra height. The Mac Mini will go probably right here once that's done printing. And then that'll be the completed thing. And then we'll have what, like 2 U's of space that we can use the covers that came with the rack to actually fill those up. But yeah, let's get the patch cables in. These are the 0.15 meter cables. Now I have a pretty bad sense of scale, so I just have to look at them. This is part of the reason why I bought so many patch cables. One is I knew I'd be able to use them in other places. But 2, because I really don't have a good sense of scale. So that is 0.15 meters. Bring ourselves over to the rack. That is pretty much perfect for this run, as well as potentially this run. Let's see. Let's put this furthest away. Obviously, I kind of want these to be somewhat in order. So if I put this here, will this be able to reach barely? Okay, so that's good to know. So these 1.5s, I think, are going to be, yeah, unless I start in the middle. Like, of course, I could do something like this, right? So I could say we have, what, 5 nodes here? Potentially a 6th node. So if we go 1, 2, 3, 4, 5, 6, so we do here. We could start there. And that looks pretty good, I think. So we'll count from port 3. This is our first node, second node, third node, fourth, fifth. We'll have an empty one for a potential 6th node, and then 2 bonus ones, which will be for the Mac Mini. Oh, you know, actually, I forgot I should run an extra cable through this opening. So I'll pull out the switch and do that. So we can have an additional one for the Mac Mini and possibly anything else we want to put in this rack. For example, might get a UPS that has built-in Ethernet. So in that case, we can plug it in there very easily. So I might actually, just for the sake of having it, I'll just run these 2 out the side here and out the back just to have those available. All of the Ethernet cables are plugged in, and that's looking pretty decent. I mean, I don't know, maybe there's a better way to route these cables, but I think that looks pretty neat. Obviously, these are the ether lighting cables, though unfortunately the flex switches don't have ether lighting, and there's also no ether lighting switch that actually supports fitting inside a 10-inch rack. So unfortunately, that feature is being unused, but either way, I think that's looking pretty nice. And then if we get a 6th node, we can run another cable. That's pretty neat. I like that. Honestly, at this point, I should probably get this cluster out of my bedroom and into the place that it's gonna be seated permanently. Unfortunately, I don't have a table yet to actually place the rack on. So for now, this will just be sitting on the ground, which I guess is a little rude to the rack, but that's fine. The Mac Mini's printing still, or the Mac Mini's rack mount is printing still. And then once that's done, we can go on and print the Protectli router rack mount. Oh, that'll probably happen tomorrow. We'll see. I might go to IKEA tomorrow and pick out just a lack or something to place this on. But we are getting very close to physical completion for the rack, of course, minus the NVMe SSDs, which are not here yet. They have actually they have moved a little in DHL. They've been placed into a sack, as far as the tracking is telling me. So it's ready to be shipped out to Canada. Still indeterminate when it'll actually show up, but it is moving. We'll hopefully get our SSDs eventually. But yeah, let's actually get this moved out of here. I thought you guys needed to see some of my just incredible ingenuity. I didn't want to have to unplug all of the little barrel connectors for the Rock 5Bs when I was moving this over, so I just stuck these into the little grates. There you go. Now they're sitting there. It looks like it's meant to be. Look at that. We have transportation functionality. Okay, so I found this like side table thing. I don't know, it's like a little rack shelf metal thing. This will work for now. I probably want to get something a little bit nicer later. You know, something to match the Rack Enterprise Edition that we have here. But anyway, there it is. From the front, looking pretty neat. Now, I'm gonna warn you, I think it's gonna be in the best interest for both of us that we just sort of ignore the situation and just assume that it'll improve later. The back is looking a little dire. Everything's plugged in at this point, including the HDMI cable and such for the display. But the power situation has left a little to be desired. I'm not gonna lie. Again, it is all plugged in, but just sort of assume that this will improve. You know, I'll set up cable channels or you know, zip ties and things later. But anyway, it's plugged in and ready to be powered on. The one thing that's missing though is that. So that's our Ethernet port, and right now that is going to my office setup. Now I do have a UniFi switch back there, which would, you know, naturally be the place I would plug our Protectli router in. However, that is a gigabit PoE switch, and it'd be nice, since this is a 2.5 gig port and we do have 1.5 gig internet here, it'd be nice to at least have a 2.5 gig link down to the router in the basement. So, small side quest, I also have this UniFi 2.5 gig Flex Mini that we'll basically use to split out. One side will go to the office, the other side will go here, and that way we'll have a full 2.5 gig link straight to the basement. Oh, and also one of the reasons that we're, you know, upstairs and not in the basement, which is where I would typically put servers, is sort of 2 reasons. Number 1 is this thing's not going to be that loud since it is just mini PCs. And 2, it's kind of cool to look at. But 3, and the most important thing is, well, there's actually going to be 2 things that require access to the sky. One is we have, if you looked at one of my previous videos for the Sineware infrastructure, you know I have an LTE failover router. I'll be bringing that here. And so that's going to benefit from being up, since, you know, it won't just be stuck in the basement. Right now it's stuck in a basement, and so the signal strength is not very good. But the other thing is the time server, which is a Raspberry Pi with a GPS module to give us a local time server from the PPS that's, you know, sent through GPS signals from the onboard atomic clocks. That'll also benefit from having access to the sky, since, you know, we'll have better access, or we'll have more line of sight to GPS satellites. In any case, let's unbox this and get it plugged in. Pretty basic, just the switch itself. I have some of the older Flex Minis, just the gigabit ones. These are just a little bit bigger. The Flex Minis are about this long. These are a little bit more extended, which is kind of interesting. And of course we have a USB-C power supply in the box. Okay, so there you go. There's the Switch Flex Mini 2.5. I just put it on the desk for now. This is a standing desk, so I'll probably move it off to the side. In any case, let's turn this thing on and see if it works. So we've got 2 switches. And theoretically, there's the Protectli coming to life. The switch is coming to life, and if you look in the back, all of the nodes have their green LEDs, so they have all turned on. The Mac, I might not have actually configured that to auto start, so let me just reach over and flip that bad boy on. Hit the power button on that. There we go, and that should power up the display as well. There's OPNsense booting. And hey, we got an upside down Apple logo. Cool, I guess I mounted the display upside down. That's mildly annoying, but I can either I can flip the display, or I can probably just do that in software. This is a touchscreen. I wonder if Mac OS. Oh yeah, look at that. That works. Hell yeah. All nodes seem to be online. Kubernetes is probably going wild, trying to, you know, bring the cluster back up to healthy status. We are good here. I don't know if I can actually see if this is on 2.5 gig by the LEDs. I guess not. I'll adopt this into UniFi. Of course, this switch is not part of our home UniFi network because it's behind the router, so we're gonna have to run a UniFi network appliance on the Mac Mini to handle that. That's one of the tasks of the Mac Mini. I don't know if I discussed what the Mac Mini is for. One is to run the display, so we'll throw up graphs and stuff with Grafana on there. The other job is to just run maintenance tasks for this cluster. So for example, running the UniFi network application for the switch. It's also going to run Tailscale, so this will be the way, this is basically going to be a bastion host, so I can use this to SSH into the cluster network, or Tailscale into the cluster network, and either use, get network access to it, or if I SSH into it, I can use kubectl. So that's basically what this is going to be. But yeah, that is looking really, really cool. In fact, you can actually see the first 3 nodes are the control nodes, and the other 2 are the workers, so you can actually see the etcd traffic causing the first 3 nodes to be very active. So that's kind of cool. So unfortunately, there is no 3D or readily available 3D model for the rack mount for this VP2420 that I have. So as you can see, I'm back in Tinkercad. I downloaded a model for the VP2440, and I have the dimensional data sheets here. I have my calipers, and I'm recreating this inside of Tinkercad with the measurements from the calipers, and then I'll modify this VP2440 model to hopefully fit the 2420. And if it does fit, then I'll upload this to printables or whatever. Link in the description as usual. But yeah, one of the great things about 3D printing, I feel like I've said this in every video, really is not that hard to hop into Tinkercad. It's a web app and just start designing measurements. Like, I'm not an engineer. So I'm just measuring the, for like getting these feet. So I'm like, okay, what's the distance between here and here? And I'm just placing down little blocks to mimic that, and then I know exactly where to place the little feet. And then now I can go in and select all this, group it together, and I can remove these blocks, and now I have a model that I can use. I can flip this over, and then using those little stubs, I can create the little holes for where the new feet will be on the model, and then I could cut out and make this whole thing. You can see how the VP2440 is actually quite a bit longer than the 2420. All right, model's done. It's in Creality Print, and now he's got to bring the Neo back downstairs and hook it up to the 3D printer. All right, so I have everything set up with Octoprint. The print just started. The bed and nozzle are all warming up, and hopefully this will be successful. As you could probably imagine, this is not the completed bracket. Although the front of it actually looks pretty nice. I did have to abort mission. I actually have another one going on right now. But I thought I might as well show you guys what happened. If you zoom in, you can see we had some layer shift going on. Now that's very interesting. Basically, I set this off to print and then I left. It's a beautiful day outside. It's like 20 degrees. Spring is finally here. However, I did forget one important thing. Of course, we're running Octoprint on the MacBook Neo, meaning the Octoprint is the one that's actually sending all of the G-code commands to the 3D printer. However, when I came back for my little outing, I noticed that the printer was stopped and it was just sitting there. And I went to the MacBook Neo and it went to sleep. I forgot to run. Actually, no, I think I closed the terminal before I left that had the caffeinate commands. If you know, on macOS, if you run the command caffeinate, it'll set a sleep lock on the computer. And so my assumption is that the computer went to sleep. However, it probably woke up a couple times, as we can tell by these kind of weird shifted layers. I assume the Mac woke up a couple times to sync, you know, email or notifications or whatever. And when that happened, the virtual machine continued to run, but presumably it lost some commands during that sleep-wake process. And so like the Mac would wake up, it would print another few layers, or you know, however many layers that is, and then go back to sleep. And then when it wakes up, it loses a couple of move commands, and so it then continues to print in a shifted manner like that. And so you can actually see that across the entire print. There's actually also, interestingly, you can actually see little blobs of filament, I assume, where the print head stopped, which is kind of interesting. Anyway, this is a failed print, so I resumed it with the caffeinate command. That's kind of unfortunate, a little waste of time, but there you go. That's a fun little failure mode. The computer going to sleep by accident. And there we go. We have the cluster in pretty much its final form. It is up, it's running. Kubernetes is deployed on it and it's running great. Obviously no storage yet, but we'll get to that in the future, not in this video. But the OPNsense router is in, racked up. You can kind of see, once again, this rack does have some weird oddities. There's the spacing of these holes is a bit weird. That's not actually consistent. Honestly, I'm not sure what they were cooking when they came up with the hole spacing. My assumption is maybe they expected you to put half view like network ports, like Keystone pass-throughs or something, somewhere in the middle, because there are like some of the holes are spaced closer to each other. Honestly, not entirely sure. So you can see there's quite a bit of wasted space there, and as well as at the top, just because the hole spacing was kind of odd. But thankfully, we were able to fit everything in. But you can see how the, well, I guess in the end, the switch has only one set of screws, and then the Protectli router has 2 screws, but in those 2 positions instead of the outer 2 positions. Oh well. In any case, I think some of you guys want to see Kubernetes in action. So let's go to the screen capture and take a look at the cluster. Naturally, I assume you guys want to actually see Kubernetes running on the cluster. So if I pull up K9s here, you can see, indeed, Kubernetes is running with all of the kube system things you'd expect, including the API server, etcd, and of course, Cilium, which is what we're using for networking between the nodes in the cluster. Another interesting part of the stack is kubevip. Since we're running a high availability control plane, this is what provides the virtual IP so that the control plane will be available at a single IP endpoint, but if any of the control plane nodes go down, it'll switch which node it's pointing to. All of this was configured with kubeadmin, so I didn't actually use any Kubernetes distribution or anything. So everything was bootstrapped manually on the first node, and then everything else was joined in and configured, including the installation of Cilium. Of course, there are many ways to set up Kubernetes. For example, you could use something like K3s or MicroK8s for a ready-to-use distribution to deploy on operating systems. There's also dedicated Kubernetes operating systems like Talos, but in this case, because we're just using plain Fedora server, I decided also just to go with a plain kubeadmin, mostly to have the complete control over how the stack is going to work, and also just to learn a little bit more. I want to get as in-depth as possible with Kubernetes here, since besides running services, this is also a great learning opportunity. Of course, we can use kubectl as well, so I do kubectl get nodes. There are 5 nodes, 3 of them are control planes. I have the taint removed on these 3 control plane nodes, so they can schedule workloads. Technically, that's not recommended, but really that's if you have a lot of nodes. Since we have 5 nodes, we want to be able to use this for workloads as well. And then the final 2 nodes are just purely workers. I can also SSH into one of the nodes. So here's node 1, and you can see all the Kubernetes services running. That's all working perfectly, so that's great. Another interesting command is this, which allows us to see how many gigabytes have been written to the eMMC. This is interesting because the node's been running for about 3 days, and we've written about 15 gigabytes to it, so that's something to keep an eye on in terms of the wear. Of course, this is a control plane node, so it's getting a lot of write activity because of etcd, which is constantly writing and syncing to the disk to ensure consistency. If I SSH to one of these worker nodes, you'll see that it's basically just idle, hasn't really written much at all. So that is the kind of interesting situation with the control planes. They're constantly going to be writing to the disk, so hopefully the eMMCs will be able to handle that. Worst case, I might end up just carving out a partition on the NVMe SSD on the control planes and then just pointing etcd there instead to spare the boot eMMCs, but we'll see. I think it'll be okay though, especially because these are 256 gig eMMCs, so we do have quite a bit of wear leveling room. And of course, just to test the cluster, even though we don't have any storage yet, I just put up a Nginx, and that is indeed working perfectly. I just have that exposed right now with the node port. So I have not done the BGP setup between Cilium and the OPNsense router. Once that's complete, then Cilium can start creating load balancers that'll be exposed to the network using BGP to the router. So that's gonna be really neat. But for now, I'm just testing Nginx with a node port. So with node port, I can actually just go to any of the IP addresses of any of the nodes and access this Nginx, since it's just gonna be exposed on a static port on all of them. So that's pretty cool. Yeah, it's totally working. So there you go. That is the basic cluster. It's running. In the future, once the NVMe SSDs come in, then I can start looking at setting up Rook-Ceph, which is going to be our CSI. So that's going to be providing the persistent volumes and such, just general storage for the databases and everything like that. And then begins the task of me having to figure out how to start moving all of the services over from Docker Compose into Kubernetes. So I'm going to have to start writing manifests for everything and figuring out a good way to migrate all of the data. I'm probably also going to temporarily set up some kind of WireGuard tunnel between the old server and this new cluster, so I can move stuff over gradually to the new cluster, but still have them exposed over the Nginx running on the old server. The idea, of course, was to make this as seamless as possible, to have as little downtime as possible. But yeah, that's a future problem to solve. For now, we have the minimal cluster running, and it seems to be working great. But anyways, I think we've finally reached the end of this video, which I think is now over an hour long. We finally reached physical completion, of course, on the cluster. There's still a little bit to do. I do want to deal with all of these cables, so they aren't just flying around. One, for aesthetic purposes, and two, because if I need to come in here and debug something or replace a node or something, it's going to become really annoying with all those cables. So that's one thing. This desk needs to change. I want to put something a little more nicer than this temporary metal thing. Of course, the screen is doing a whole lot of nothing right now, but that's only because we don't have any of the services running. Once I have stuff in the cluster, I can set up a Prometheus and a Grafana for observability, and then I can create a Grafana playlist or something to go up on there. But yeah, the cluster is basically ready. Once the NVMe SSDs get in there, it's ready to start running services. So that is pretty cool. I'm pretty happy with how this turned out. I think it's a nice little setup. But yeah, I hope you guys enjoyed the video. It was a lot of fun setting this up, and there will be more like this. So be sure to subscribe and like all that good stuff. Oh, and also feel free to sign up if you want a Mastodon account, on the Fediverse, or a Matrix for chatting. You can go to sineware.ca and get an account. And well, depending on when you're watching this, you'll either be running on this cluster or you'll be on the old server. Anyway, thank you guys for watching, and I'll see you guys in the next one.